Hello there everyone, and welcome to this workshop or course on data engineering with Python and MongoDB. My name is Valentine and I'll be your instructor. In this course, we are going to get started with understanding the objectives of the session. After that, we'll get into a 10-minute session where we get to talk about what data engineering with Python and MongoDB entails, why we would want to perform the related concepts. And then after that, we'll get to go into a practice session where we will get to see how we can work with these two technologies, that's Python and MongoDB. We'll showcase various concepts as well as code examples on how we can implement those concepts. And we'll also give you challenges that you can use to practice and be able to get better at working with the two challenges, with the two technologies together. Then towards the very end, we'll just talk about the next steps. So let's get started. By the end of today, we are expected to have achieved these learning objectives or learning outcomes. We should be able to demonstrate the process of extracting, transforming, and loading data using Python scripts and MongoDB. We should also be able to develop efficient data pipelines that automate data processing tasks using Python. We should be able to explain why MongoDB is suitable for specific use cases, and we should also be able to apply best practices for data handling in Python and MongoDB environments. So what is data engineering with Python and MongoDB? This is a process that involves the use of Python as well as MongoDB, which is a type of database that allows us to store unstructured data. So it involves the use of those two types of technologies to create what are called data pipelines. These are just systems that allow us to collect data, transform data, as well as store it efficiently for other stakeholders who might want to use that data. Could be maybe other data engineers. It could also be other data scientists or analysts. MongoDB, more specifically, is a type of NoSQL database. So when it comes to working with data, we tend to store it in different data storages. And we can store data in what are called SQL databases or relational databases. And in such types of databases, data is structured in a tabular format. On the other hand, in situations where we have unstructured data that does not conform to that tabular format, then we can use a tool like MongoDB to store that type of data. So the reason why it's written NoSQL is because when we work with structured data that we store in relational databases, we use a language called SQL or SQL to interact with that data in those systems. And such systems might be Postgres, could be MySQL, SQL Server, Oracle. Those are relational databases, and we use SQL to interact with those systems in order to retrieve, update, delete data. But when it comes to MongoDB, we do not use SQL. This is a different type of database that stores data in what is called a document format. The format looks more like what is called JSON, where you have more like dictionaries kind of format, where you store data in key value pairs, and you can have dictionaries inside of dictionaries. But that's the easiest way to explain just how you store data in MongoDB databases. So generally, MongoDB is designed to handle large volumes of unstructured data. So in cases where SQL databases might not be able to hold unstructured data because of maybe cost constraints with regards to maybe costs for memory, or in other cases, then in such situations, MongoDB can be an alternative. MongoDB is document oriented. It stores data in a document format, and it's one of the many types of databases that we can use to store data in that type of format. Just like you have MySQL for relational databases, you have now MongoDB for we have for document-oriented for documents, for storing documents. There are other alternatives, but our focus will be to work first of all on with MongoDB. But again, we can always leverage other tools, other NoSQL databases if we want. A good use case to just help us understand how we might be able to use these two technologies. That's Python, which is a programming language for performing lots of tasks. You can perform data analysis, you can perform machine learning tasks. So a use case where we can be able to perform both would be, we could end up creating a data pipeline that would contain just a component for loading or for collecting data or extracting data from a MongoDB database. Then inside that data pipeline, would transform that data we've collected, say, from a MongoDB database, and then we would store it maybe in a different MongoDB database or even in another database. But this is that's just one example. Another example would be we can create a data pipeline to collect user interaction data from an e-commerce platform and transform that data using Python, using a library like Python, a library like Pandas in Python, and then store the outcome, that's the transformed data, in a MongoDB in an effort to, say, generate personalized product recommendations in real time. So other applications can be based off now that data that has been cleaned using the pipeline that we've developed. So that's just one use case. There are many use cases. Just to give you a good example, that was just actually those two. I gave you two examples. So generally, why we would want to use MongoDB as well as Python would be because we might want to have a design of a data source that does not necessarily take into consideration of the structure of data. So we may not necessarily want to store data taking into consideration whether there are some missing values, whether some records have lots of values, and MongoDB helps us store data in that what is called schemaless design, which technically allows us to just work with just diverse data types and structures. On the other hand, still we can use Python to manipulate that data and transform that data easily using standard tools in data science such as Pandas. MongoDB can also scale horizontally. So if we have large volumes of data, even within one MongoDB database, and we would want to store related data that is larger than the existing data, then MongoDB allows us to be able to scale horizontally and be able to handle that kind of data. While again, on the other hand, Python allows us still to be able to perform data analysis on that growing amounts of data. Pandas has a bit of capability on handling a lot of data. But also, on the other hand, we also have the Dask library, which is provided again by Python, that we can also use for handling lots of data, performing just data pre-processing tasks. Again, on the other side, we have, when we use Python, we have lots of libraries at our disposal. We have machine learning libraries, we have data visualization libraries, manipulation libraries, and also when we use MongoDB, we can also query data in a complex way. One more thing is that both also work together. There's a library for interacting with MongoDB databases called PyMongo that allows us to integrate Python as well as MongoDB with ease of use, as opposed to maybe some new types of data sources that have emerged that might be a bit difficult to integrate the two. But yeah, so generally, those are some few reasons why we might want to use MongoDB as well as Python all together. Whether that means in storing data initially, or alternatively loading that data that we have transformed somewhere. We might decide to store that data because it's transformed and it's unstructured in a particular data source. When might we not want to use Python and MongoDB? Maybe if we have a strict schema, like that we need to adhere to, in cases where the data that we need to work with needs to have specific data types, then we can decide to use just traditional SQL databases such as Postgres, as well as MySQL. If our application also requires complex multi-document transactions, and in such situations, then we can decide just to use, again, a relational database. In such situations also, the types of transactions might require that they follow this format of atomicity, consistency, isolation, and durability. This is a design that we would normally implement when it comes to efficiently storing data, especially in relational databases. If the data we are collecting seems to if the research questions that we are solving as data engineers seem to require that kind of an approach, then we can just resolve to working with relational databases. For advanced analytical queries and complex joins across multiple tables, then we might opt to use other types of databases called columnar databases. Apache Cassandra is one of them. And also there's also another one called Amazon Redshift. When we want to handle maybe extremely large data sets, other than, and we realized, yes, MongoDB will be able to handle large data sets, but it can get to a point where the cost of scaling MongoDB clusters, which are just the environments where we would store our databases, MongoDB databases, if the cost of scaling becomes quite prohibitive, it becomes too much, then we can consider just other cost-effective data warehouse solutions like Google BigQuery and also Amazon Redshift. So those are just a few reasons why we might not necessarily want to use Python and MongoDB. But in many cases where you just have unstructured data, as well as a bit of structured data, a mix, which is a mix, then in such cases where we don't require that, then we can just simply use other technologies. Right, so at this particular point, I'm going to ask you to visit the resources link, the practice resources link. It should take you to a page that looks like this, and you can click on the sample practice resource. Now we're going to go into our practice work. So the sample practice resource will look like what you're seeing on your screen. In addition to that, we are going to be required to create an account with MongoDB. The reason is we can actually, so MongoDB, we can use it. We can actually store it within our web servers. It's available for use for commercial purposes for free. But the only issue is that right now we don't want to focus on just installation locally. We could use a tool like Docker to be able to pull an image and set up a MongoDB instance locally. However, in order to quickly get started, you can click on the MongoDB link that we've also shared just below the practice resource page and create an account on MongoDB on their website. And once you've created an account, you'll end up to a page that looks like this. Once you've gone through the first few steps, they might ask you a few questions, etc. But you'll get to a page that looks like this. So if you click on the left, you'll see, if you look on the left on the deployment section, you'll see that database is selected. So this is where we want to end up and we are going to create what is called a cluster, which is just an environment, a MongoDB database environment that we can be able to use in order to get started working with MongoDB or storing data in MongoDB databases. So you can pause the video and do that. The first one, open the sample notebook. If you're an Afterwork member, open the practice notebook. You'll have all the challenges that you need, as well as the solution notebook that you need. But if you are just here to just quickly learn. Consider just going through, just clicking on that sample resource link, and it should take you to this page, and we can quickly get started. So once you're done with that, the next thing that we need to do is to install, go through the first set. So once you've opened that, just go to File, then save a copy in Drive. To save a copy of this notebook, to open a new tab, then use the new tab, the notebook that you've opened, and close the original one. I'll open mine in playground mode because I don't want to make any changes to the original copy. To just take a few seconds. All right, so once we have done that, the next thing that we need to do is to import pandas for data manipulation. So under prerequisites, actually we can click on connect at the very top. Just click on connect to connect the notebook to Google servers. Once you've gotten here on this account for also MongoDB, just hold it off. Just continue with what we are doing in the sample notebook. All right, so our notebook will connect, and once we are done, we can just import pandas SPD. Just click on run anyway. So we'll import pandas. We'll also install the PyMongo library, which is a library that allows us to interact with the MongoDB instance that we have, or database that we have. So install that and also import it. So once you've installed it, the other thing that you need to do is to import it. So yes, you can install it, but you won't be able to use it until you have imported it. So that's what we are going to do in the next section. So here, click on import. Yep. So the other thing that we needed to have done, which I have explained, is to just register or create, just register on the MongoDB website. That's MongoDB cloud.mongodb.com. And once you get here, then we can continue after. All right. So I hope you've gotten through that step. The next thing that we are going to do is to now go through the MongoDB platform. We can always host MongoDB locally, but now what we normally do is to deploy what are called clusters, or to have what are called clusters. Clusters, you can think of it as an environment that contains databases for, say, MongoDB. So in MongoDB, we would have a cluster. Then inside a cluster, we would have databases. Then inside databases, we would have collections. But we'll get to that in a few. So let's first of all build a cluster. So build a cluster, click on that link, build a cluster. Just call it whatever that you want, but click on M0, the one on the far right. It's a free for just learning and exploring, and just you can call it cluster 0. So free, then cluster 0. We can just leave these ones as they are. It just sets up a MongoDB in any of these providers. Just then just click on create deployment. Yeah, so once it has done that, the next thing that you need to do, it's still creating your cluster. But then you can pause this video and then we'll continue and continue as we continue, but I'm just going to continue throughout. Feel free to pause the video and you can always catch up and rewind. So here we are going to create a username to connect to this particular cluster. I can create mine, I can call it student, I'll call it student1, and a password, I can just auto-generate a secure password, and I can copy that password. So I highly advise you to copy that password somewhere. It could be in a text editor locally, could be somewhere. Just copy the password somewhere else, somewhere separate. It could be a notepad somewhere. So, and also, so the password is as well as the username. So mine is student1. Then I'll click on create user. So go back, create user. So it will display that, it will show that it has created a user over here. I had created an earlier user, but I can always remove that later. So that's it. So the next thing that we need to do, let me delete this. I don't need this. You don't need to delete what I'm deleting. Okay. So the next thing that we need to do is to ensure that it's to allow that we want to ensure that our cluster can be connected from anywhere. So you could have a specific computer that runs your Python code, but then it needs to connect to this cluster, MongoDB cluster, and retrieve records. For security purposes, one can restrict the IP addresses that you would want to have to interact with, the IP addresses of the devices that you would want to interact with the MongoDB cluster. So for example, here you could add an entry, etc. You can remove them, but I don't know why mine is not. I can click on, let's say here. Okay. Let me see if I can remove this. Okay, it's not removing. Okay, all right. We'll do this in a few. Let's just click on. You can click on, and you can click on. Initially, it's not like this. Okay, we'll change that later. Just click on finish and continue, and say go to clusters. Just finish and continue. We'll set the IP addresses in a few. So our cluster has been created, and it's called cluster 0. And if we wanted to, and also it has, we have a sample data set that has been loaded to that cluster. We could decide to, visit the cluster and be able to explore it. So if you click on cluster 0, you can get some more information about that cluster. Okay, right, it's giving me a small issue. Let me refresh it again. It will take me back. Take a few seconds. I think sometimes it may be taking a few seconds or so, or a bit more time. But yeah, okay, let's click on connect, the connect icon, to just be able to get some piece of information that we need to connect to it. So click on connect. Mine will be different from yours, by the way. Then click on drivers. Then what we need is this particular case. We need this string, and what I'm going to do is to copy. So click on this copy link, copy this. It's add your connection string. We need this, copy that, and paste it where you had also pasted your password somewhere, add your username and password somewhere separate. And what we will need to do in the string, you need to replace the name username. See the name username on the string, the one that I'm highlighting. Actually, not the name, the actual, including the greater than, less than sign. So that bit, the brackets, is it the less than and greater than characters? You need to replace that with your username. So my username is student1. Let me show you what I'm going to do. And password, also the same case with password, so that I'm doing it somewhere else, but I can be able to display it on the far top. Not sure whether you will be able to see. On the far top of your screen, you should be able to see my string on the URL. So you can see MongoDB, then student1, then my password, double colon, my password at the very top. So I hope you're able to see this particular place. Let me highlight it. So this is my password that I've replaced, and also this is, that's my username. This is my password. So you'll need the entire string. So you can, again, once you've done that, just copy it somewhere and paste it. That's the one that we're going to use to connect to our database. So just say done once you're done. And once it's done, we should be good to go. You can now explore your data set, your cluster. So you can click on view collections. So inside, so I had mentioned to you in MongoDB, you have a cluster, which is the environment that contains your databases. Then you have databases. So here we have one database. We have sample mflix. So we can create another database. So create another database called sales. And it should have a collection name called products. So sales, then products. To take a few seconds. Sales, then products. Again, that's the first one. Now I want you to create another database called customers, and it should have a collection name called orders. Customers, then collection name orders. So MongoDB has a cluster. In a cluster, you have multiple databases. Here we have 3 databases: customers, sales, and sample and flicks. That's a default database that was added when we created this cluster. Inside the database, you have now what is called a collection, and a collection would contain documents, multiple documents. All right. So if I click on let's say any of these, you will get some more information about what exactly will be found here. But yeah, so generally, that's what we need to set up on the side. But there's one more thing that we need to do. By the way, if you click on customers data, okay, let's not do that. But if you click on, let's say, customers, you'll get what you're seeing here, the customers database. You'll get some information, some statistical information about what's contained in that database. We have this collection. We can have another collection. You can think of collections like more like tables, that kind of an approach, but they're not tables essentially, but they're like, in a database you have tables, but now in a MongoDB database you have collections. Then in collections you have, in one collection you have, like the way you have records in a table, you have documents, but now in a collection you have documents. Hope that made it a bit more clear. Okay. All right. So the other thing that we need to do, we need to provide network access to this cluster. So we can click on network access. So network access, yes, network access. Here I had this particular, I'll delete this first one. So here, no, I think you'll get this just one IP address, which is what I have here. But if I want to connect from Colab or even from a specific IP address, I would need to add the IP address here of that particular device. It could be a web server, etc. But for now, we just want this cluster. One can be able to connect it from anywhere. So what I'm going to do is to click on IP address at the top right, add IP address. Then I can click allow access from anywhere. We can remove that. I don't even know why I'm getting changed, but do that and then just say confirm. That should allow us to be able to connect to our cluster through any sort of IP address, through any device. Okay, so it will just set it up, take a few seconds to do that, and then we will just now move on to our sample notebook. Then we can now work from there. So I'm just waiting for that to be done. You can also wait for that to be done. Pause the video and also do that as well. Okay, so while that continues, we can go to our sample notebook. So we have just finished importing and also setting up our MongoDB cluster. So first of all, the approach that we've taken in this session, we are going to learn how to work with MongoDB and Python. And then in the last section, we'll just learn how to build data pipelines. So working with MongoDB and Python, so we'll learn how to connect to MongoDB, how to insert data, like a lot of data. It will be helpful when it comes to loading data, how to update the documents in a MongoDB cluster, how to also delete documents. Yeah, so those are the 4 essential strategies or tips that we're going to learn. So I think this is also continuing. It is active. Okay, all right, we should be good to go now. Let's now go to this first section, connecting to MongoDB. So here, we are first going to connect to a MongoDB connection or database. So first of all, what we need to do, we had already imported our MongoDB library, so we need to establish our connection. So we use PyMongo, which is the library that we have imported, and we use the Mongo client function, and we specify we use the string that we had copied and also updated our student name. So here I'm going to use my student name. This is different from what I had. So I'm going to get my student, the string that I have updated. And if you get an error, just know that you get an error. And you'll also note that most likely you might not be able to run the existing code because it does not, the cluster I had created for just testing has been deleted. So yeah, so we'll connect to this cluster 0. And then when you look closely at the string, you can see just information about cluster 0, which is the cluster that I have created. And I then, in the next line, once I've connected to the cluster, I specify that I want to use the sales database. The sales database is the one that we created earlier. So if I click on database, if I go to database, let me even just zoom in over here. If I go to database and click on cluster 0, you'll be able to see that. No, let me just go back. View, browse collections. Okay, that would have done also the same thing, collections. But yeah, so here we have customer sales, but I want this sales database. That's the one that I'm specifying here. Then I want the collection products. So under sales, there's products. So that's the one that I want to specify. So I want to connect to that, and also I want to list the collections within that particular products collection. So or the documents within that particular collection. So I can, once I have gotten DB products collection, I can iterate through by just using the find function. I apply the find function to the collection, and then I use the list function to list out the results of this, and which will be just the products, which will be in a list format. Then I can iterate through a list with a Python list displaying each product. Then I can close the connection. So let's run this. Oh, sorry. At the very end, what did I do wrong here? Invalid syntax. Let me see. There's something I am missing there. Okay, I see what's happening. So I need to remove this. I hope it's not in other lines. So that we have client is what is given the end. So your code needs to look like this for the string. I hope you're able to get that right as well. Right, so if you run this, you should be able to get your products. Yeah, so generally, that is what you would need to do. We can do a whole lot of other tasks, but for now, the reason why, someone might ask why we're not getting any products. It's because we don't have any products stored. So we're not getting any outcome. So, but essentially, we've been able to connect and to that particular case. Some issues that you might get might be because the student one, you forgot maybe a less than or equal sign in the credentials section of the string, so you need to remove that less than or greater than, and also the password might be wrong. So yeah, but if you are still facing that issue, you could always still go to database access, and then you can go to add a new database user or edit the existing user and change maybe the password. But again, use the student name and the password that you have, but you'll need to give access to that particular role, read and write access for that. All right, so that's it. Pause the video, then work on the challenge, and then we should be good to continue. So once we have learned how to connect to a MongoDB database, the next thing that we need to do is to insert maybe some documents. So here we have just a list of dictionaries. It's a list, then inside we have multiple dictionaries. So a document would look like what you have, here. Like this is one document, this is another document, this is another document. It contains just information about just whatever that we want. So here we can say products data will contain what we have here. Then we connect to our instance, and then we again specify the database as well as the collection. And then we can use the insert to many. So once we get the collection, instead of using find function, we say insert many, and then we specify the products data, which comes, it's in the format of a list of dictionaries. So the data that we would need would be in this particular format. Then once we do that, we store the result in result. Then we can just print out what we have inserted and then display what, and then display that. I will print it out and display the same thing. Yeah, but now here's the issue. You need to keep on replacing the string that I have here. So yeah, so let's do that. Let's replace the string, because the IP address as well as the username is different. So you always need to do that. Otherwise you'll get an error. Run that and you should be able to see what has been inserted. So you can see what has the IDs of what has been inserted. There are 3 different objects. If you go to databases, you know, the database itself, click on browse collections, we should be able to see now our collection. So if I click on sales, just clicking on the name sales, okay, double clicking on it. If you double click on sales, you should be able to see that we have 3 documents that have been inserted. Then you can click on products, that's the collection name, and be able to view the collections, the different documents. So this is the first document that we've inserted, the second document, and the third document below. All right. Awesome. So let's continue. Now you've learned how to insert data. Just note that this method of insert many, using this method, we will be loading data in our data pipelines using this approach. Updating documents in MongoDB. So sometimes you might want to update data documents. So assuming we wanted to update, so in our case here, product A, wanted to update this, the price for product A to maybe 60. Then we can do that. That is shown. Also the quantity as well as other, say, attributes or fields. You can call them either of the name. Even fields just works. So we connect to our MongoDB instance. So here, change this to your string, which I have now. Then connect to sales database, products collection. Then we specify how we want to update our document. So we specify a filter criteria as well as it's like a condition and then the new values that we want. So the filters criteria, we want to check for where the name is equal to product A, and we enclose that. This is a dictionary. And also in another dictionary, we specify the new values, and we use this particular case for the key set, just the $ set, want to set price to be for product A to be 50 and also quantity to be 60. If we had just only one update that we wanted to make, we would just have only one update, just like that. All right, so once we have done that, we can then use these 2 pieces of information, that's the filter criteria and new values, to update now our record. So here we have if you wanted to just update a single document, we can do as shown. So we decide to say filter criteria, we pass update 1 to the update 1 function, filter criteria, then new values as well, and we update that to the products collection, and we get to have our results. But here we just specified we want to display now here how many modified records did we have. It's greater than 0, document updated, the document not found. So here we had product A, which is the one that we have here, and the price has been updated, will be updated to 50 and quantity 60. So we run that and we should be able to display our results. So document updated successfully. Okay, pause the video and then work on the challenge. By the way, for the previous section, you can also pause the video if you're an Afterwork member and work on the bulk insertion challenge that we had here. We also have a challenge for that. Yeah, here. Okay, moving on, updating. I think we've done that. Deleting documents. So sometimes you might want to delete documents, maybe just one. And in our case here, we can see that here we are connecting to our database. So this is a string that we need to update. Let me change. I've updated the string to mine, and then we delete. You can delete maybe just a single document using just the delete one method, and we pass now the condition, the method. We just want to delete one. So we want to delete one where the name is product A. So this is a field name and the product name. And we can also delete multiple documents using the delete many method, and we specify the dictionary that contains our definition. So where category is category B, and then we close the connection. All right. Yeah, so that's generally how you're able to do a whole lot of some of the tasks that we have showcased so far. So those are just important tasks. We've learned how to connect to a MongoDB cluster and a database and also collection, and we've been able to also insert, update, delete. So what we're going to be doing is now to learn how to apply the same concepts when it comes to building data pipelines. If this is your first time going through this workshop, it's okay, just bear with us. We have done other data pipelines workshops in the past, but our focus for this session will be on how we can be able to use, again, Python as well as MongoDB. Again, you applying the same concepts. I think it's a whole lot easier for someone who has gone through other workshops to also go through this workshop, because the concepts are usually just the same. The implementation is usually what's different. So let's start. We'll start by just creating a simple data pipeline. Oh, by the way, I had forgotten. Work on the challenge if you're an Afterwork member. Pause the video and work on the challenge. You will thank me a lot in the next sections once you worked on the challenges. All right, so creating a data pipeline. So you mentioned a data pipeline has three different components. There's the extract component, there's the transform, as well as the load component. In many cases, that's a structure or the design that we might want to use. And that's what we're going to use. And for each and every of those components, we're going to create Python functions. But we'll also create just another one for just connecting to the instance MongoDB cluster that we want. So to do that, first of all, we're going to define a function to connect to our database, which is what we have here. So we can update this as well. And yeah, we specify just what, the collection that we want to work with. So we want to pull data from our documents from this collection. So that's what we are returning from this function. And then the next thing that we do is to define the function to extract data. So the extract component will extract data from this collection that we get from the connect database function. Then we list out those particular products and we return that. And then once we have done that, we will pass now this data to the transform function, which will use pandas to transform that data. Here we just creating a pandas data frame, and then we can perform pandas data manipulation. By the way, we have a 30-day pandas challenge. If you really want to learn how to transform data, that is for you. So consider also going through that to supplement your learning journey. Once you have done that, once the data has been transformed, and this is just one transformation, just converting the collections, the documents to pandas data frame, we can then pass it to the load function, which loads it to a desired destination. But here we're just displaying it. We're not loading it. We're just learning how to extract data and implement it in a pipeline, which we are doing it here, extracting the data, and then we're just displaying the data. Then lastly, we execute the pipeline. Normally, we would have this code saved, the entire code in this code cell saved in a .py file, and then we can always execute. We can always set what is called a cron job to schedule when this particular file the code will be run, or the file will be run. So we could always save this code somewhere, and then we might want to run the code in this file every midnight. So we can create what is called a cron job for that. That's why we have so many sessions to go in the future. So consider, subscribing so that you're able to also be informed when we have maybe a cron job session for that, which will essentially allow you to just learn how to automate some tasks or schedule some tasks. So once we have done that, the next thing that we need to do is to just run. So to define how we want to execute our pipeline. So here we are calling this function connect database, and then we are passing this particular, we are calling this database, this function, which is returning our products collection. And then we pass products collection to the extract function, which returns sales data. Then we pass sales data to the transform function, which returns transformed data. And then we just display the data that we've loaded. So let's run that and see what we get as a result. So here we have displayed our data frame, which is here. We are using print df, but I can just remove even the print function. So to just appear in a print data frame. So okay, it hasn't. Let me just use that. Yes, it should. Let's just use this instead. So just use a print function. If you run that, you'll get the data. You'll get the actual document that exists in this particular products collection. The reason why you have only one is because we deleted we deleted one here and also deleted another one here. So we have the C1 product C that's remaining. So this essentially is a pipeline. What you see here is a pipeline, but there are best practices for this. Like for example, for this string, you do not usually have your authentication details in a string. You would have a variable, then that variable would be stored in an environment file where you store your environment variables, which are just sensitive data, which you only just use separately and define separately elsewhere, because this file might be maybe uploaded to GitHub or Bitbucket or whatever, GitLab or whatever repository that you might have. So there's some best practices that we can still apply here, but this just does the task. Initially, when you are a one-man team, they may not really matter most, but of course, over time, you need to consider now applying best practices. But again, our focus was just to learn how to extract data in our case over here. Right, pause the video, work on the challenge that we've shared here. Yeah, so, and if you're an Afterwork member, remember, you could always verify your challenge with a solution that we also have. So you can have a look at the solution notebook for that challenge. Moving on, transforming data in pipeline. So this example will just give us an idea of how we can be able to transform our data. So assuming that we had the CSV file, our data was in this CSV file, and we wanted to store this data inside a MongoDB data set after we have pre-processed it. Then what we can do is to collect this data. So we can get this data using the read CSV function, store it in sales data. Then once we have stored it there, we can then decide to preview it. Yeah, we're just previewing it for the purpose of this learning experience, but normally you wouldn't. But when you're developing, you could, so that you have an idea of what the kind of data that you are extracting. So extract function will, I'm skipping this deliberately, by the way, because this connect function, connect database function, we will use it down here. We'll use it when we are loading data, not initially. So we're extracting the data, then passing the extracted data to the transform function, which again, we rename the column names of the CSV data that we have using the rename function. We use this approach. We can use other approaches. It's just one of the approaches for data cleaning. We have a 30-day data cleaning challenge. Always consider that on our channel or on our platform. So yeah, just to get better at data cleaning. So once we have done that, we can then decide to perform some other tasks and data cleaning tasks. And once we have done that, we can then return this data and pass it to the load function. And we also specify now the data set, the database, the MongoDB collection that we want to store this data, the transform data to. And then we also define that we also want to pass out the result from the transform function. And then we, inside the load function, we specify the operation that we will use to load the data to our products collection. So we use the insert many, remember from the previous section, insert many method, and we pass now to this method the transform data dot to dictionary record. So we are simply using pandas to transform our records from the pandas data frame to a dictionary format, to a list of dictionaries that we pass to insert many, which automatically stores it in a MongoDB instance. And basically that's it. Here we're just calling the different functions, how you just define our pipeline. And voila. So if you actually copy this code, it may not necessarily work. You might need to import some libraries. We are not importing the libraries in this section because we had imported them earlier. But if you copy the code as it is and run it locally and having fulfilled that the requirement of pandas as well as MongoDB, PyMongo, then it should work fine. So if I run this, I'm going to see what? Okay. Oh yes, I did not replace the string. Let's replace the string. The string over here. Then we run it. We should be able to see our table. So this is the printed out extracted data that we had. Okay. Pause the video if you're an after work member and work on the challenge. All right. So here we've learned how to extract data from a CSV file, then store it in a MongoDB instance. Here we learned how to simply extract from a MongoDB instance and just display it. But here we can also decide to do the vice versa of extracting, then loading it into a CSV dataset or CSV file. Maybe some stakeholders who are in your organization might be well versed with working with CSV files, so you can create a data pipeline to just be able to bridge that gap, that deficiency of not working. Okay, I'm speaking badly, but yeah, so I'm just saying you can be able to help stakeholders who don't have knowledge of working with MongoDB be able to work with the data stored in MongoDB. So here we define the MongoDB function. So I'll update my string as well. And then I connect and I get the products collection. You can use either of the variables, products collection, doesn't matter. So I get it and I pass that collection to extract function, which will just simply extract the documents within that collection. Then once I do that, I can then be able to define my transformation function. Here, for ease of learning, we're just converting the data into a pandas data frame, and then here we're just loading it to products. We pass the pandas data frame using the toCSV function to this particular file. Again, this is just a pandas function. We also have some good idea of how to work with pandas function. Here we set index to false because we don't want to include an index column in our final data set. And then we run the code. So if you click on the far left, where we usually have a file section, if I run this code, I should be able to see the files, the products.csv data appear here. So just run that. And then it should show up in any second, maybe a few seconds. If it doesn't, you can always click on this icon. It will show here. You can always download it by clicking on the three icons, drag your mouse on top of here, then click download. Or you can always double click on the icon and you'll get the table on the far right, one that we want. All right, pause the video and then work on the challenge if you're an after work member. All right, lastly, some best practice. We had mentioned that we'll learn how to apply best practice. So sometimes you might get errors. Maybe sometimes the data that has been stored is, it's in a funny structure or something of that sort. How we can be able to ensure that our pipeline continues to perform. We might decide to use what are called try except blocks that allows us to just be able to catch errors that we might face within our code. So yeah, and even not only this, you could also decide to, another step is to provide logs. Like, you could always have you can always track how your data is being transformed or extracted within your pipeline by logging in some messages, like once once you've gotten to return, or not even return, once you've gotten to get the collection, you can have another line, have a log statement that logs that data has been retrieved, or documents have been retrieved successfully from the collection, and do the same case. It helps to just be able to just monitor your application. So here we are using a try except statement, where inside the try in the body of try, we store the code that we want to execute, and if there's an error, it will be raised here as an exception, and we can be able to see the error that was raised, and later onwards deal with that later. Like you'll see right now, I won't update this string, and if I get to run this pipeline, I'll be able to get an error, but the error will be in this format: error connecting to the database. Then it will give me the actual error. So that's what we do. We do that we apply that statement for all the functions, and also when we are calling or defining our data pipeline, we also decide to check for if the collection is, if it's empty, then if it's not empty, if it's empty, we won't be able to execute anything. So we need to execute it when it has collections, it has documents. So the next line over here will be executed only if the collection has documents. The same case, this data that is a result of the extract function, if there's something, if it contains something, then we will be able to execute the next line of code. This is just to ensure that your pipeline is quite compact, it follows best practices, etc. Like for example, right now I'm going to run this. I'm not going to update my string, but I'll get an error here. Error connecting to the database. The DNS query name does not exist. MongoDB. It's because it doesn't exist. So it means the cluster doesn't exist. So I can just update mine right now. And if I change maybe student 1, I remove the 1. If I run this, I'll get a different error. Error extracting data. Bad authentication failed. So it gives me an error. So I can know what to do. So authentication, so it should be student 1. So if I run this, everything should work now correctly. Data loaded successfully, which we have here, and that's what technically we had here. So yeah, that's it. Pause the video, then work on the challenge, and then we can continue. All right, so we have gotten to create just data pipelines. Initially, we got to learn about what MongoDB entails, why we would want to use it. We also got to learn why we would also want to use it with Python. We got to create an instance, create a cluster, create a database, as well as a collection of within a database for MongoDB. And we were able to load our data into those collections remotely from a different web server, which contains our code. Our focus still, when it comes to working with MongoDB and Python for creating data pipelines, this is usually more of a getting started learning experience. Our recommendation is to create data pipelines that possibly get data from different sources, maybe from MySQL databases. That data then is combined maybe with one particular other database, and essentially you transform that data and store it maybe in a different database, not only just a MongoDB, but maybe in maybe a different type of database. But the idea here is that you have gotten started with MongoDB, and I hope you got to understand what this process of creating data pipelines with MongoDB entails. In the future sessions, we are going to be building up to what we have. Say we're going to use, maybe when we get to learn how to work with Redis, which is a database type of database that allows us to cache data. We are going to be using some of the concepts that we've learned. So yeah, I hope you got to learn a lot, and hope to see you in the next learning experience. Yeah, continue practicing. And if you haven't become Afterwork member, what are you waiting for? You'll get lots of practice. Yeah, so that's it. If you like this video, be sure to give it a thumbs up. If you'd want to be informed when we post such future videos, be sure to subscribe.